Okay guys, in this section we begin to look at the 6 trigonometric functions, and we're looking at them in this section in terms of their right triangle definitions. And so the scenario that we have here is we have theta as an acute angle of a right triangle. So that's our scenario. Then these are the definitions of the 6 trigonometric functions of that angle theta. All right. Now, before we dive into these, let me just say this. Okay, sometimes students have trouble understanding really what sine, cosine, tangent, and these 6 trigonometric functions are. But here's how you need to think of them. Remember, these trigonometric functions are exactly that. They're functions much in the same way that square root is a function. So like, for example, square root by itself is not a number, right? But square root of 25 is a number. So you can think of these as the same way. Sine by itself is not a number, okay? But sine of 90 degrees is a number. Does that make sense? Or sine of 2 pi radians is a number. Does that make sense? Okay, so that's how you need to kind of think about these functions. You can think of them as functions much in the same way that square root is a function. Okay, so that kind of gives us a little bit of framework to go in and work with. All right, so if you've got a right triangle, then based on your reference angle, wherever the reference angle is, you've got an opposite side, which is across from the reference angle. You've got the adjacent side, which is the side that's connected to the reference angle, one of the sides of the reference angle. Then you have the hypotenuse, which is always across from the 90. All right, so in a right triangle, one of the angles is going to be 90 degrees, right? And so these 6 trigonometric functions are defined in terms of those 3 sides in a right triangle. All right, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. This is cosecant, hypotenuse over opposite. Okay, secant, hypotenuse over adjacent. And cotangent, which is adjacent over opposite. Now, in geometry, okay, you typically stop with these 3, sine, cosine, and tangent, right? And the reason why is because that anything that can be done with cosecant, okay, it's just the reciprocal fraction from sine, right? So if you've learned about everything that you need to do as far as that involves the opposite and the hypotenuse can be done with sine, so that's why geometry typically doesn't go into cosecant, right? Because anything that you can solve with cosecant, you can also solve by setting up with sine. And then the same is true for the other 2, which are reciprocals, right? So these are reciprocals, and then these are reciprocals. All right, so like I say, geometry typically stops at sine, cosine, and tangent. Okay, but now in the Precal course, we pick up the other 3, cosecant, secant, and tangent, right? And these 3 are reciprocals of these 3, okay? All right, so kind of how does it work when we're actually looking at problems here? Well, the first thing that we have to make sure that we are good at is setting up the correct ratio, right? And so if I have my right triangle here, and we know already if this is 3 and this is 4, the hypotenuse has to be 5. We know that. Okay? So if I wanted to write out the trigonometric functions for this particular triangle, right? So remember, sine is opposite over hypotenuse. Well, in this particular triangle, remember, theta is my reference angle, so the opposite and the adjacent are in terms of the reference angle. So I need the opposite side. Well, the side across from the reference angle is 4. The hypotenuse is 5. So in this particular triangle, the sine of theta equals to 4 over 5. All right, so cosine, adjacent, the one that's adjacent to the reference angle in this case is 3, and the hypotenuse is still 5. Opposite over adjacent would be 4 over 3. For cosecant, hypotenuse over opposite would be 5 over 4. Basically just the reciprocals of all these, 5 over 3 and 3 over 4. Okay, so again, Opposite and adjacent are always positioned based on your reference angle. Opposite is across. Adjacent is the side that's connected to that angle. That's one of the sides of the angle. And then hypotenuse is always across from the 90. All right, now remember, opposite and adjacent sides could change depending on if your reference angle changes from here to here. All right, if my reference angle were here, then 3 would be the opposite. Okay, so keep that in mind. Opposite and adjacent are based on the position of your reference angle. Hypotenuse never changes. All right? And so now what kind of problems are we going to be looking at doing here? Okay, so what we've got is we've got right triangles, and we have something that's missing. All right, so in this case, it's this bottom side of the triangle that's missing. So what you want to do is you want to look at the two pieces that you have, right? And based on the two pieces that you have, decide which one of the 6 trigonometric functions you're going to use to set it up. Well, here's my reference angle, 52. We've got the adjacent side, and we've got the hypotenuse. All right, well, adjacent and hypotenuse, you can either use cosine or you can use secant. Those two involve the adjacent and the hypotenuse. So you have your choice there. You can pick either one. Either one would work. Let's use cosine. So I'll go cosine of theta is equal to the adjacent over the hypotenuse. All right. So I typically like to say that it's good practice to write out the equation first and then fill it in. Right. Cosine of the reference angle is 52. Right. The adjacent side is x, and then the hypotenuse is 13. All right, so it's just good practice to write it out first and then fill in, just to make sure that you're keeping everything straight like you should. Okay, so from here now, we just have an equation that we need to solve for x, right? And remember, cosine of 52 is just some decimal number, much in the same way that square root of 52 is some decimal number. Does that make sense? So remember, this is just some number. That's the way you would treat it when solving the equation. Probably best thing to do here would be to just multiply both sides by 13 and let's get an answer. The 13 will cancel out and leave me with x equals, which is what I want. So I need to now figure out what 3 times the cosine of 52 is. All right, so we can go into our calculator and we can go 13 times. If you go to functions on Desmos, then that's where your trig functions are going to be. So that's going to be cosine 52. And we get this answer, which is negative 2.11. Now, here's another thing that you got to make sure that you consider here. Okay. Remember last time we talked about degrees and radians? You want to make sure that your calculator is set to the same unit of measure that's given in your problem. So here we're given degrees, 52 degrees. So I need to go up here to this little settings and make sure that I'm set to degrees and not radians, or I'll get the wrong answer. You got to make sure your units match up. So once you do that, then we can see that our answer is 8. Okay. So once again, make sure that your units are consistent with your problem and your calculator, right? And up here is kind of where you change that. All right, let's go ahead and see if we can set up the next one now. Locate the reference angle. We're 51. We have 8 as the opposite side. We have x as the adjacent side, opposite and adjacent. That means we could either use tangent or cotangent to get the answer. Either one. Let's go with tangent. So it'll be tangent of the reference angle, okay, equals opposite, which is 8, over adjacent, which is x. And actually, I just violated the principle that I just told you to use a while ago. Opposite over adjacent. And writing out the equation first really does 2 things for you. Number one, okay, it helps you make sure you keep everything straight in the right place when you plug it in. And number 2, it just helps you to memorize and become familiar with the equation. After you write it out several times, you'll probably memorize them if you don't have them memorized already from geometry. So this will be tangent. My reference angle is 51. My opposite side is 8. My adjacent side is x. And once again, I've now got an equation that I can solve for x. Let's get x out of the denominator, multiply both sides times x. Then we'll have x times the sine or tangent of 51 is equal to 8. And to finish this, I'll divide both sides by the tangent of 51. That'll leave me with x equals, which is what I want. And let's see what it is. Okay, so now we'll go, let's see, 8 divided by, go back to my functions. And I need 8 divided by, what did we say, tangent of 51. Is that right? Yeah. And then so we get 6.47. 6.47. In keeping with the directions, we'll round to the nearest tenth and just call it 6.5. So sometimes the directions instruct you to round to a certain value. When it does, make sure that you're following those directions. All right. What do we got next? Okay, so on this one, here's my reference angle. I have the opposite side, and I have the hypotenuse, opposite and hypotenuse. You can pick sine or cosecant, which, by the way, either one would give you the same answer. Just keep that in mind. Let's go with sine. So we'll go sine of the reference angle is equal to opposite over hypotenuse. Now we'll go back and fill in. So we've got sine. My reference angle this time is what's missing. So I want you to notice that. So my reference angle, I'm going to put in as an x this time. Okay, so one of the sides could be missing, or in this case, the actual angle itself is missing, and that's fine. We'll show you how to solve that as well. So now the opposite, 6, the adjacent, or excuse me, the hypotenuse is going to be 12. So I've got sine of x equals to 6 over 12. All right, and so, and by the way, you could also leave that as a theta if you want to. And so from here, okay, we've got to ask myself, okay, I've got an x that I need to try to solve for. And this is a lot of times what some people miss when they're going through this in geometry. Okay, the reference angle is what's missing. So what's happening to the reference angle? You're taking the sine of the reference angle. All right, you're taking the sine of the reference angle. Okay, so what that means is we need to do the inverse of that function to both sides to get sine out of, or to get the x out of there. Okay, so no, it's not divide both sides by sine, because remember, you can't just divide by a function, because a function in and of itself is not a number. That would be like saying, let's divide both sides by square root. Doesn't make sense, right? Okay, so the question is, how are we going to get x out of the sine function, right? Okay, well, we need to, like I said, we need to find the opposite, the inverse function, right? So remember we talked about square root a while ago, right? Square root, the inverse function for square root is squared, all right? So like, for example, if I had square root of 25, that's equal to 5. But if I do the opposite of that, 5 squared, I get back to 25. You see what I mean? So like, for example, if I write this, what's the square root of 5 squared, right? 5 squared is 25, and the square root of that is going to be back down to 5. You see what I mean? So how would I get 5 out of the squared function? I would do the opposite function, square root. So how do I get x out of the sine function? I do the inverse function, which is, by the way, inverse sine. So that's kind of a long explanation of what we need to do to both sides, which is take the inverse sine. All right? But hopefully it's clear now to everyone. So I want to take the inverse sine to both sides of this equation. And as you recall, the inverse function, it almost looks like to the negative 1 power, but that's not what it is. That's the notation for inverse. All right? And so inverse sine and sine get together. They just kind of wash each other out, and the x falls out. Because remember we said 5, the square root of 5 squared is 5, so the inverse sine of x is x, kind of in the same fashion. So we need to figure out what the inverse sine of 6 over 12 is. Okay? So again, I'm going back to my functions in Desmos, and I need the inverse sine of 6 over 12. If you want to write that as 1/2, you could, and we can see that our angle now is 30 degrees. All right, so 30 degrees is our angle theta in this case, 30 degrees. Okay? All right, let's see what else we got. Okay, so on this next one, we have our reference angle. Okay, we have the opposite side, and then we also have the hypotenuse, opposite and hypotenuse. Okay, I could use sine again, but since we used that last time, let's just use cosecant so that I can show you that that also works as well. All right, so in this case, what we're going to do is we're going to say that cosecant of theta is equal to the hypotenuse over the opposite. Okay, so remember, make sure you write out the equation first. So cosecant, my angle is 75, equals to the hypotenuse is x, right? And the opposite here is going to be 6. All right, so make sure you're plugging in the ratio correctly. And so now we can multiply both sides times 6. And so when that happens, that'll cancel out and leave me with x. And so I like to put my x on the right hand or on that left hand side, just a preference. And so let's come back in now and go 6 times the cosecant of 75, and then we'll get 6.2 as our answer there. Okay? One more to practice for us here today. And so on this one, we have a reference angle that's missing. We have the opposite, and we have the adjacent. All right, so opposite over adjacent. We could use tangent, but we already had an example with tangent, so let's do an example with cotangent. And so what we'll have is cotangent. Uh-oh, I lost my light. Hold on a second. I got to wave my arms back and forth. There we go. Cotangent, the reference angle equals adjacent over opposite. Now let's plug in cotangent of x, because the reference angle is missing, equals to adjacent 13 over the opposite, which is 10. Okay? And so now here what I need to do is I need to get x out of the cotangent function. I can do that by taking the inverse cotangent of both sides. Okay? And so inverse cotangent and cotangent cancel each other out pretty much. For undo one another is probably a more proper term, because canceling refers to numbers that divide out to 1, so these are not numbers. So instead of canceling out, I should probably more correctly say that they undo each other as far as what that number would be concerned of for x. And so now I need to go back to the inverse cotangent of 13 over, you can't see that, 13 over, what was it? 13 over 10. And so we get 37.6 as our answer here. All right, so in this lesson, we're just using the 6 trigonometric functions in order to set up and solve problems in right triangles.